Okay, here we go. We're live. So today it is 1/3/2020. Wow. Okay, our objective is finding angles from the unit circle. Okay. Did you get them? So, example 1. This is sine of theta. So we really want to find the angle. We want to find theta, which is our angle, right? And we're going to use a unit circle to do it. So before I even start, I'm going to write a couple of things down that's really going to be helpful, right? Let's see if I got to grab it while you guys are getting ready. Where's my pen? So I'm going to add 3 things that are really going to help out, okay? So when we're looking for a sine of an angle, we're looking for a y value, right? We're looking for a cosine of an angle, we're looking for an x value. And we're looking for a tangent, we're looking for the y over the x, but those are, we already did those, right? We did all of those, so let's put your phone away. And these are basically those outside numbers. Mine are green here, right? Mine are green, but it's the outside numbers. So if we're looking for a tangent, those are our, I'll call it our outside numbers, okay? Those are our tangent values. On my unit circle, it's my pink ones here. On my circle, on the big circle up there, it's the green ones, okay? So this is actually pretty easy. And we always want to find the one that's close. Always our angle. We want to find the angle closest to 0. Because a lot of these have 2 or even 3 possible answers. I mean, we saw that when I went through it. Some of these have 2 or 3 possible answers. We want the one that always goes 0. So we'll start with example 1, which I think we can do. So sine of theta equals 1/2. Well, we're going to look at the circle. I want a y value of 1/2. 1/2 is here, the y value, right? And 1/2 is here. So we're either at 30 degrees or 150 degrees. What's closest to 0? 30. Right? What's my angle? Theta equals 30 degrees. Now if I need that in radians, well that's easy. I mean, what's the radian equivalent? Pi 6, right? Okay. So it's okay, or pi over 6. Same angle, different name, right? Same angle, different name, okay? Okay, number 2, look for cosine. Cosine is the x value. Square root of 3 over 2. I see it in 2 places. I see it here at 60. I also see it for cosine
120.
here.
120.
Oh, I'm in the wrong place. I need cosine for x value.
120.
Oh, no, you're...
I'm
Oh,
here.
you're the x value.
I'm here. Yeah, see, I was wrong, wasn't I? You guys agree? So I'm either at 30 degrees or I'm at 330 degrees. Which one's closer to 0? 30, right? It's got to be 30. It's not that hard, right? So we'll go theta equals 30.
Wait, yeah.
And tangent.
Are they not?
Yeah, they're both
Would you just choose the...
one that's always closest. Yeah, choose the positive, yeah. And then I'm going to actually put,
It's positive, but it's 30
They're both,
degrees
yeah.
away from 360.
let me answer that question. You ask a very good question, okay? So one more time, I'm going to put this up here. So for the sine of any angle, they're found in quadrant 1 and 4. Okay, you guys know what the quadrants are? 1 and 4. Okay. Cosine. This is going to answer your
For
question.
sine.
Yeah, for sine. Cosine of an angle is found in quadrants 1 and 2, and we do not take the answers in 4. Just 1 and 2, okay? And your calculator does the same thing, and we come back next week, we'll start to look at the graphs of these, and you'll really see once we put the graphs, okay? Yeah, and then the tangent, to find the angle, is found in quadrants 1 and 4. And of course, when we're in quadrant 4, it's the negative angles. I'll show it again. When I'm in quadrant 4, when I'm right here, I got two choices. I go all the way around,
What do you mean?
or you just go back down, right? We're gonna go the shortest distance. That makes sense, which is the negative angle, okay? Thank you, Autumn. That's a good question. Okay, now let's keep going. So, Autumn, you're right. So, cosine, we only find the angles in quadrant 1 or 2. We don't take answers from 4, right? Or in radians, theta is pi over 6, okay? How am I doing? Thumbs up? Okay, tangent. Now, tangent, these are my values that we already did all that work. They're the ones on the outside. So, where do you see 1 for tangent? 45. Awesome. And now there's a second one, but who cares? You got the right one. Right? And the other one's here, but that's too far away. Agree? So 45 is totally right. So theta is 45. So I get theta equals 45 degrees. And if I need that in radians, what's my radian equivalent? Pi fourths. Boom, right? Sine is 1. Now, sine's a y value. Do you see 1 up there for y value?
Wouldn't it be 45 degrees?
Okay, come on, somebody find it.
Wouldn't it be
So y value of 1,
90.
90. Yes, there it is. Okay, 90, right? Okay, so theta equals 90. Or what's the radian equivalent?
It's not.
Pi over 2. Yeah, same angle, different name, right? Okay. Cosine of negative 1/2, okay? So we're looking for a x value of negative 1/2. X value of negative 1/2. You guys see it?
240 degrees?
240 is correct. Is there one closer?
120.
120. Okay, which one's closer?
120.
Right, so we want the 120. You guys catching on to this, okay? Theta equals 120 degrees. What's the radian equivalent?
2 pi.
Yeah, 2 pi thirds. Okay, good. Okay, number 6 is a trick question. Sine of 2. Now think about this. It's a trick question. The unit circle. What's the radius of the unit circle? What's the radius of the circle? So I can go to 1, but can I ever get to 2? Is it on the circle? This was no solution. No solution. Nothing. No solution. Does that make sense why you can't get 2? I mean, if the radius is 1, to get to 2, you're off the circle, correct? Okay, good. All right, example 7. Sine of theta equals negative 1/2. Okay, I need a y value of negative 1/2. Where do you see it? Awesome, 330, okay. 210, okay, which one's closer?
330. No, it'd be 210 because 30.
Negative 30 is closer. Yes. Yes. You guys agree? I mean, do you want to go, check it out, do you want to go all the way there? Do you want to go all the way there? Or you want to just like go there? That's closer, isn't it? Negative 30. Good. So theta is negative 30. Or what's the radian equivalent? Yeah, but that's going, I mean, you're right. You're totally right. Oh, Parker.
Wouldn't it be a negative pi 6?
How about a negative pi 6? Who said that?
Oh,
Negative pi 6. Or a negative pi 6. I mean, Parker, you're right. That's too long of a run, man. That's like going all the icicle when I could just, right? You know, yeah. I mean, I'm going home, I'd go all the way on the icicle. I could just jog home, right? Yeah. Okay, tangent. So tangent, oh, that should be a 3. That's a mistake. That'd be square root of 3 over 3. Change that, please. That is a mistake on my part. So, where do you see negative square root of 3 over 3 for tangents? Remember, it's the outside values. Either way, yes. Autumn already found it. Autumn, say it. She said negative 30. I mean, you can also have it here, right there at 135 degrees. You also have it, or not 135, that's what it's, at 150. You could go all the way around to 330 degrees, but Autumn went straight to negative 30. Okay, it's negative 30, shorter, right? Good job. So theta is negative 30 degrees. What's the radian equivalent of that? Yeah, it's just negative pi over 6. Good. Okay, now calculator. So if we want to do this in terms of radians, okay, we're going to get an angle. The angle is going to look weird because it's not going to look like an angle because, think about this. Okay, before we do this, right here, pi, that's an angle, okay? Pi, that's an angle, right? What is pi? 3.14, that's an angle, okay? So 3.14 is an angle. What? 3.14 is an angle. So change your calculator radians, and we're going to get angles, but they're not going to seem like angles. They're going to be these weird decimals. So go to my mode, change my mode to radians, right? So make sure your calculator looks like this, okay? Okay, everybody change their all the way through like this, so you're in radians, right? Okay, go ahead and put your calculator like this. And then we can go, now if I want the angle, what button do I push? Yeah, so I'm going to go sine inverse of 0.56. Now the answer is going to seem weird because it's not going to seem like an angle at all, but it is. Sine inverse of 0.56. I get an answer of 0.594. Theta equals 0.594. Okay? Now that's a decimal, but it is an angle. 3.14 is an angle. Okay? That's an angle. So 0.514 somewhere around here. Okay? Same thing. Tangent of negative 0.4. So if I want to find the angle, what button do I push? Inverse. I'm going to go tangent inverse of negative 0.45. Tan inverse, my calculator, right, of a negative 0.45, and I get an answer of about negative 4.22. Now negative makes sense because we've been getting negative answers, haven't we? Negative 0.422, which means the angle is down here. The angle's down here is it's negative, right? Okay. Yeah, it's easy. All you're doing is just use God. Now, example 3, cosine. How are we going to find the angle? Okay, we're going to go cosine inverse of 1.3. What do we get? It doesn't work. Why not? It's bigger than 1. If cosine is the x, here's 1, right? Where's 1.3? Maybe about here. You're off the circle, right? So it's undefined. No solution. No solution. Okay, guys ready to turn the page? Not too bad. Not too bad. The unit circle is actually pretty easy. As long as you're here every day and you pay attention, it's not hard. Okay, turn the page. Okay, now, example 11. It's a tangent and, guys just calm down. Okay, okay. So draw a triangle. So it says draw a triangle. We're going to draw a triangle, okay? Draw a right triangle because it's trig. So draw a right triangle and put theta in there, okay? Draw a right triangle, put theta in there, okay? Because theta is our angle, right? So, before we do anything, we know that cosine of some angle is equal to the adjacent over the hypotenuse, okay? So I'm only doing this first part. Okay, I'm doing this first part right here, okay? All right, so that means my 3 is here and my 5 is there, correct? So I drew a triangle. I knew cosine of an angle is equal to the adjacent, which is 3, and my hypotenuse is 5. Now, if I want the tangent of this angle, the tangent of the angle is the opposite over the adjacent, right? But I don't know the opposite.
4.
It is 4. How do you get 4 so quickly? Well, you knew about 3, 4, 5. It's a perfect right triangle. But if you don't, then we would use Pythagorean's theorem, right? Okay, so totally right. So you could go, okay, 3 squared plus b squared equals 5 squared. And you do get 4. Nice job. Totally right. Okay, and so we put the 4 in here and we can finish this problem. Now to finish the problem, we want tangent of theta is the opposite, which is 4 over 3. Okay, let's do one more of these, okay? Okay, it says draw a triangle. So I'm going to draw a triangle. Draw a right triangle because I'm doing right triangle trig. Okay. So I got cosecant and tangent. So first of all, tangent. Tangent of theta is equal to my opposite over my adjacent, okay? But I got a 0.2. Well, I can change that into I need a fraction, right? I can change this decimal into a fraction. I gotta have a fraction. Yeah, 2/10. Totally right. So 2.2 is the same thing as 2/10. Totally right. And we can even reduce that to 1/5, right? So let's rewrite this. So the problem is really cosecant tangent inverse of 1/5. Okay. Nice job, Caden. So I just changed my 0.2 into 2/10, which is 1/5. Okay. So now I can build my triangle. Okay. Tangent is the opposite over the adjacent. Okay. So I've got the 1 opposite over adjacent 5. Now, I don't know the radius because if I need the cosecant, what I know about cosecant of an angle is equal to the hypotenuse over the opposite. Okay, but I don't know the hypotenuse, but I can use Pythagorean's theorem, right? So I go a squared plus b squared equals c squared. I'd go 5 squared plus 1 squared equals c squared. 25 plus 1 equals c squared. 26 equals c squared, or the square root of 26. So you know what I did by getting that is I can put that into my triangle, right? And then I can finish this up. So to finish it up, I want cosecant, which is the hypotenuse over the opposite. So my answer is the square root of 26 over the opposite, which is 1, or the square root of 26. Okay, that's a little bit harder, but we can do it. Okay, so when you see these today in your homework, draw a triangle. When you see this stuff like this, the double trig, draw a triangle. Okay. All right. What do you think? Thumbs up. You okay? All right. Let's look at the homework, and we've got time.